Right now, two oceans on opposite sides of the planet are behaving in completely opposite ways at the same moment, and the result has forced every major forecasting agency to rewrite its predictions. That's not an exaggeration. This week alone, both NOAA and Colorado State University issued updated hurricane season outlooks that are dramatically quieter than what they published at the start of the year. The reason comes down to a pair of ocean signals almost nobody expected to line up at the same time. One ocean is running record warm. The other has just developed a cold anomaly so rare that if it holds through the season, it will be only the sixth event of its kind in more than 40 years of recorded data. And here's the part that defies intuition. Two opposite temperature anomalies in two different oceans, moving in totally different directions, are pushing the atmosphere above them the same way, not against each other, together. Understanding why that happens and what it means right now is what this is about. Start with the Pacific, since that's the one everyone has been watching. The story has been building since late 2025, and by mid-2026, it's no longer a forecast. It's a confirmed reality. The Niño 3. For region. The standard patch of the Central Equatorial Pacific scientists used to measure El Niño strength was already running about 0.98 above average across April through June. In June alone, that number jumped to 155 degrees. By the most recent weekly reading, centered on July 15th, it had climbed to 2 warmers. That's a rapidly accelerating warm-up, and it puts this event solidly in strong El Niño territory with the trend still pointing up. The World Meteorological Organization puts the odds of El Niño conditions persisting through July-September at 90 or higher, with similarly strong odds. It holds through the peak of hurricane season. Severe Weather Europe, among the first outlets to flag how big this was, is now calling it a potential super El Niño, tracking toward record strength, with parts of the eastern Pacific running 34 degrees above normal. That's a massive redistribution of heat across the planet's largest ocean. That air absorbs, moisture becomes lighter and rises. As it climbs, it cools, the moisture condenses, and you get towering storm clouds and heavy rain. That rising air has to go somewhere once it hits the top of the atmosphere, so it spreads out and eventually sinks somewhere else, creating higher pressure and drier conditions there. It's a closed loop. Every column of rising air is paired with sinking air somewhere else on Earth. El Niño takes the massive engine of rising air that normally sits over the western Pacific and Indonesia and drags it thousands of miles east into the central Pacific. That's the essence of El Niño. It relocates the engine. And wherever the engine moves, the compensating sinking air moves too, showing up in new places, including over the tropical Atlantic. While everyone was fixated on the Pacific, the Atlantic did something almost no one was tracking. In mid-July 2026, a stretch of ocean along the equator running from West Africa toward Brazil started cooling not slightly but sharply enough that within days it appeared as a stark blue patch on global sea surface temperature maps standing out against warmer water on either side. Temperatures in that stretch ended up running 13 degrees below normal severe weather Europe, which caught this early, noted that if the seasonal anomaly that reaches 0.5 and holds 2026, will officially qualify as only the 6th Atlantic Niña event in over 40 years of records. That's genuinely rare. A naming correction matters here. This is not La Niña. La Niña lives in the Pacific. It's the cold phase of the same oscillation that produces El Niño. And by definition, you can't have El Niño and La Niña running simultaneously in the same ocean. What's happening in the Atlantic is a separate pattern entirely. The Atlantic zonal mode. Zonal refers to bands running along lines of latitude, which is exactly what shows up on the map. A horizontal band of cold water stretching east to west along the equator. Like its Pacific cousin, the Atlantic zonal mode swings between a warm phase, Atlantic Niño, and a cold phase, Atlantic Niña, every few years. These are driven by different mechanisms on different timescales and studied by a much smaller group of researchers, largely because they're far harder to model. The fact that almost nobody outside the field has heard of this pattern isn't because it's unimportant. It's because the tropical Atlantic is the one ocean basin where climate models are consistently demonstrably wrong. Every major generation of climate model shares the same bias. They run the tropical Atlantic too warm, not occasionally consistently across every modeling system, including the newest ones. In seasonal forecasting, this error shows up within the first month of a model run and reaches close to full strength within about 6 months. Because that bias suppresses the very cold water feature that defines an Atlantic Niña, the models are poorly equipped to capture what's happening right now. That's not a minor academic footnote. It's the most important ocean basin for a huge share of the world's population, and our best tools underperform there, specifically. The mechanism isn't mysterious. The eastern equatorial Atlantic already runs on a counterintuitive seasonal cycle: warmest water in spring, coldest water in July and August, the height of northern hemisphere, summer when the sun is strongest and surface temperatures still drop below 77 degrees. The reason is wind trade winds blow from the southeast along the equator, and because of how Earth's rotation affects fluid motion, wind blowing along the equator doesn't just push surface water forward, it pushes it sideways away from the equator in both directions at once. The surface layer effectively splits down the middle to replace it cold water from several hundred feet down water that's been sitting in the dark, away from sunlight rises to fill the gap. That's upwelling one of the most powerful processes in the ocean. In 2026, trade winds across the equatorial Atlantic have been running stronger than usual. Stronger winds mean more aggressive splitting of the surface layer, more upwelling and colder. Surface water, no exotic physics, just wind doing its normal job harder than usual this year. Here's the piece that shouldn't work, but does, and it's the central fact that makes this combination so remarkable. One ocean is record warm, the other is abnormally cold. Instinct says these cancel out, and the atmosphere lands somewhere near average. That's not what's happening. The two signals are adding together. The reason traces back to the same rule: the atmosphere only cares about where air rises and sinks. El Niño has already shifted a huge column of rising air from the western Pacific into the central Pacific, and the sinking air that balances it outlands in several places around the tropics, including directly over the tropical Atlantic. That's the remote effect. At the same time, the Atlantic's own cooled surface is independently suppressing rising air, right? There, colder water means less evaporation, less moisture, and heavier air that sinks rather than rises. So the tropical Atlantic is being pushed down from two unrelated directions at once. One push arriving remotely from the reorganized Pacific circulation. The other generated locally by the Atlantic's own cold surface. Two independent mechanisms landing in the same place, doing the same thing. Forecasters have started calling this an atmospheric shield over the Atlantic basin. Not an official meteorological term, but one coined by severe weather Europe that has caught on because it fits. Sinking air means higher surface pressure, suppressed rising motion, stronger upper-level winds, and reduced rainfall precisely. The conditions hurricanes can't work with storms. Need warm surface water for energy, rising moist air to build height and calm upper winds, so a developing storm is torn apart before it can organize. This setup removes all three at once across the Atlantic's main hurricane nursery, the stretch of ocean from West Africa to the Caribbean, where most serious Atlantic hurricanes originate. That process usually starts with African easterly waves, disturbances that roll off West Africa every few days in summer. Most fizzle out, a few catch the right mix of warm water, rising air and light upper winds, and organize into storms. Right now, the Atlantic Niña is cooling the eastern half of that nursery. The combined sinking air is choking off the rising motion storms need, and El Niño's wind shear is tearing apart anything that tries to organize. The shield isn't partial. It's layered across the whole nursery. This is why major agencies keep revising their 2026 season outlooks. Dow NOAA's latest update from August 6th now puts the odds of a below-normal season at 75, up sharply from 55, just weeks earlier. Their current range, 7 with D, named storms 26, reaching hurricane strength, and possibly 0, reaching major hurricane status. Category 3, Colorado State University, issuing hurricane forecasts since 1984. And one of the field's most respected voices is now projecting just 9 named storms and 4 hurricanes for the whole season, which would make it the least active Atlantic season in over a decade. For comparison, a typical season produces 14 named storms, 7 hurricanes, and 3 major hurricanes. 2 storms Arthur and Bertha have already formed and dissipated, so the remaining activity expected through November is genuinely minimal by historical standards. NOAA notes that every strong El Niño since 1950 has coincided with a below-normal Atlantic season, every single one. This is where coverage of these patterns usually goes wrong. A below-normal season is not a canceled season. Quiet describes averages and totals, not any individual. Storm 1992 and 2004 were both relatively quiet years by storm count, and both produced some of the most destructive hurricanes in U.S. history. Hurricane Andrew in 1992 devastated neighborhoods south of Miami, and stood as the costliest natural disaster in U.S. history for years. One storm, finding one gap in the shield, a brief lull in wind shear over water that's still historically warm near the coast, is all it takes. Nobody experiences the seasonal average, People experience the storm that hits their community. A quiet forecast means better odds. It doesn't mean zero risk. The angle that gets almost no coverage because American audiences are focused on U.S. coastlines is what this pattern means for people on the other side of the Atlantic. The same cold band of equatorial water, creating the shield for American hurricane season, sits directly beneath the engine of the West African monsoon. The monsoon runs on the temperature contrast between ocean and land. Warm ocean water pulls moist air upward and pushes it inland, where it eventually falls as rain over the Sahel, the semi-arid belt south of the Sahara, spanning Mauritania, Senegal, Mali, Burkina Faso, Niger, Chad, Sudan, Ethiopia, and neighboring countries. For the hundreds of millions of people, their rain doesn't arrive year-round. It comes in one short growing season, typically June through September. If it fails, arrives late, or ends early, there's no second chance, no backup source, no alternate window. A cold Atlantic, Niño weakens moisture. Supply at the source, meaning the monsoon carries less water. Inland, meaning the rains that entire communities and food systems depend on come in below what crops need. The gap between a warm Atlantic year and a cold one isn't a weather statistic for the Sahel. It's the difference between a harvest and a failed one. And it's unfolding this same summer that's making American forecasters cautiously optimistic. This is also why the Atlantic's model bias is more than a technical complaint. The models underperform in exactly the basin that matters most to the world's most vulnerable populations. A forecast error that means a few more or fewer U.S. storms is an inconvenience for emergency planners with the resources to adjust. A forecast error in Sahel, monsoon timing, or rainfall totals is a humanitarian consequence for populations with no institutional safety net, no food reserves, and no margin for a bad year. That asymmetry between who benefits from better forecasting and who suffers from its gaps is something researchers are actively working to close, but the work isn't finished. This event is happening now. The Pacific side of the shield looks locked in for the rest of hurricane season. El Niño is still strengthening, and July data shows the ocean-atmosphere coupling becoming more established, meaning the Pacific's influence will likely intensify, not fade, through August, September, and October. The Atlantic side is the wild card, the Atlantic. Niña depends on sustained, strong trade winds, and the upwelling they drive trade. Wind bursts are inherently more variable than a large-scale Pacific oscillation. If winds relax for a stretch, warm water from surrounding areas caps the cold anomaly, and it fades within weeks, removing one leg of the shield, while El Niño's leg stays in place. The shield would weaken, not vanish. Heading into winter 2026 to 2027, the Pacific story takes over almost entirely. Strong El Niño events have a well-documented effect on the North American winter jet stream, pushing it south, bringing wetter, stormier conditions to California, the desert Southwest, the Gulf Coast, and Florida, while pushing milder, drier conditions into the Pacific, Northwest, Northern Plains, and Great Lakes. Southern California can likely expect above-normal precipitation. Texas and the Gulf states a stormier-than-average winter. The northern tier milder temperatures and less snow. This is a far better established signal than anything in the Atlantic, and winter forecasts will lean heavily on it. But there's a third signal complicating the picture. A cold anomaly in the far North Atlantic, distinct from the Atlantic Niña, and sitting in a different region, has been building and could persist well into winter. Cold anomalies. They tend to shift pressure patterns across the North Atlantic, affecting storm tracks, and how strongly El Niño's winter signature reaches the eastern U.S. and Europe. Forecasters are calling this a tri-headed pattern, the Super El Niño in the tropical Pacific, the Atlantic. Niña near the equator, and the cold North Atlantic blob up north, all active, simultaneously interacting in ways no seasonal model captures perfectly. This winter could be one of the most dynamically complex in years, and that uncertainty isn't a failure of meteorology. It's an honest reflection of how complicated the atmosphere gets when three major ocean signals are all live at once. The real takeaway is the specific numbers. It's the shape of what happened. Two oceans on opposite sides of the planet developed opposite anomalies for entirely unrelated reasons, on independent schedules, and nobody planned this combination. No forecast at the start of 2026 predicted both patterns running at this intensity by midsummer. The Atlantic Niña, in particular, wasn't on most radars, partly because the models underperform there, and partly because strong summer events like this are simply rare. And yet, when the two signals arrived together, the atmosphere didn't average them out, it added them. The reason is basic physics, not exotic interaction. Both patterns suppress rising air over the Atlantic for different complementary reasons, and an atmosphere that can't rise in a location, can't build hurricanes there. The Pacific moved its rising air engine elsewhere. The Atlantic independently cooled its own surface. 2 suppressions landing in the same place at the same time. We spent the first half of 2026 watching one ocean closely. The other changed while almost nobody was looking, and it turned out to matter just as much. That's worth sitting with. Not as a knock on forecasters working with genuinely limited tools in a genuinely difficult basin, but as a reminder that the climate runs on multiple timescales in multiple ocean basins simultaneously, and our models capture some of those signals far better than others. The open questions. Now, how quiet will this hurricane season really end up being? Will the Sahel get the rain it needs? Will the Pacific El Niño peak at the strength currently projected? And will the cold North Atlantic add a third layer of forcing to the winter pattern? All of it is still unfolding in real time, on a planet that isn't waiting for the models to catch up. Stay informed, stay ready, and stay alert.